Okay, so in this video I'm going to have a look at surds. Surds come from the Latin surdus, which means deaf or mute. But from our point of view, a surd is going to be the root of a rational number whose value or whose result is irrational. So for example, if we take the square root of 2, so we're looking at the square root of 2. The square root of 2 will be irrational, and if you stick that into your calculator, you'll get something like 1.41421356, and so on, and it'll fill the screen in your calculator. And in fact, no matter how big your calculator is, this number is going to go on forever. It'll fill the screen, it'll never repeat, it'll never recur. So you can't express this number here as a fraction. So a surd then basically is the root of a rational number. Remember, 2 is our rational number. So 2 can be expressed as a fraction, 2 over 1. However, if you get the square root of it, you get this number here, and this number here is irrational. So root 2 is a surd. Square root of 2 is a surd. Now, it doesn't have to be square root, it can be the cube root, the fifth root, the seventh root, the ninth root, whatever it is. But in this case, the square root of 2 is an irrational number, and square root of 2 here will be a surd. In fact, the square root of any prime number, will be a surd, because the square root of any prime number will be irrational. Okay, so formally, I mean a surd then. The surd is the root of a rational number whose value, or well, let's say result, is irrational. Okay, so let's have a look at some surds and see different things we can do with them. Well, just two basic rules for surds. If you have let's say the square root of a multiplied by the square root of b, you can write that as the square root of a times b, and vice versa. If you got the square root of two numbers multiplied, you can split them up into the square root of a times the square root of b. Similarly, if you have the square root of some number over the square root of another number, you can write that as the square root of the fraction. So for example, if you have, let's say here, the square root of 12 times the square root of let's say 3, well, you can write it like this. You can write that as the square root of 12 times 3. So that's just simply the square root of 36, which is 6. 6 times 6, or 6 squared, will give me 36. Similarly here, if you take let's say, if you have, let's say we'll do it in reverse here, 27 over, or no, we'll do square root, yeah, we'll do square root of 27 over the square root of 3. Well, you can write that as the square root of 27 over 3. That's square root of 9. So that's just 3. That's just applying these two rules. Okay, so let's just move on then. So let's take this number here, square root of 8. Now, if you type in square root of 8 into most calculators anyway, press equals, what you'll end up with is 2 root 2. That'll come up on the screen. How does your calculator do that? Well, if you take the square root of 8, that can be written as the square root of, let's say, 4 times 2. 2 fours is 8. It's exactly the same thing. So using our rule above, that's just the square root of 4 times the square root of 2. Square root of 4 is 2. So we end up with 2 root 2. Some other examples of that would be, let's say the square root of 45. Well, that's just the square root of 9 times 5. 5 nines, 45. That's just the square root of 9 times the square root of 5 using our rule above, and that's just square root of 9 is 3 root 5. Let's take another one. Let's take square root of 300. Now what you do here, in fact, what and you may have noticed this, is you take the number under the root symbol here and you look for the highest square number that will divide into that number. So a square number is, our square numbers, I'll just list a few of them here. Let's say if we take 1, square it, you get 2. Sorry, you square 1, you get 1. Take 2, square it, you get 4. Take 3, square it, you get 9. 4, square it, you get 16. So this is, let's say, x, and this is x squared here. 5 will give us 25. We'll do one more. 6 is 36. So these numbers here, all of these numbers here, they're called square numbers. There's a number that you can get the square root of all of these numbers, and you will end up with a whole number, in other words. So what's the highest square number that will divide into 300? You must look for the highest one. Now the highest square number that will divide into 300 is 100. Because remember, what we're going to do is apply this rule and get the square root of this number eventually. So if we multiply that by 3, that will give me 300. 3 times 100 will give me 300 here. So again, I can split that up. That's square root of 100 times the square root of 3. And that just gives me 10 root 3. Square root of 100 is 10. Okay, let's do one more. Let's take root 98. Now, what's the highest square number? What's the highest square number that will divide into 98? Well, it's actually 49. 49 is 7 squared. So what do we have to do to that? Well, if we double it, 2 49s will give me 98. So that will give me square root of 49 times the square root of 2. So square root of 49 is 7 root 2. So the square root of 98 is 7 root 2. Okay, so let's have a look at adding and subtracting these things, these surds. So let's have a look at an example. Let's take square root of 99 and let's subtract the square root of 44. Now you can't subtract these as they stand. What you usually have to do is turn them into some number times a surd. So do what I've just done up there. So let's take our 99 and find the highest square number that will divide into 99. Well, it's actually going to be 9. So it's going to be 9 times what? 9 times 11 will give me 99. Now let's do the other one. This is 44. Well, the highest square number that will divide into 44 is 4. Multiply that by 11. What do I end up with here? Square root of 9 times the square root of 11. Here I end up with the square root of 4 times the square root of 11. Square root of 9 is 3. Root 11 here. Square root of 4 is 2. And root 11 here. Now these two I can add, or subtract in this case. I've got 3 of these root 11s minus 2 of these root 11s. And if you remember from algebra, we can only add and subtract like terms. It's similar here when you're adding and subtracting surds. So here we have, it's like 3x, if you like, minus 2x. That will give me just x. So this is the kind of thing we're doing. Because we have the same surd here and here, we can add them or subtract them. So 3 of these root 11s minus 2 will just give me 1 root 11, or just root 11. Okay, so let's try another one of those. Let's take square root of 125, and this time we're going to add square root of 20. Let's see what we can do with these. Well, square root of 125, we can't add them, they're not the same at the moment, so let's try and make them the same, if you like. So let's take 125. Well, the highest square number that will go into 125 is 25, and we would have to multiply that by 5 to give us 125. The highest square number that will divide into 20 is 4. We would have to multiply that by 5. 4 5 is 20. So here we've got square root of 25 times the square root of 5. Here we've got the square root of 4 times the square root of 5. Square root of 25 is 5. The square root of 4 is 2. So here we've got 5 of these root 5s. We've got 5 of these root 5s. And we have 2 of these root 5s, and we want to add them. So our answer here will be 5 plus 2 is 7 of those root 5s. Okay, so that's just adding and subtracting surds. Now, just finally what I'm going to do is just multiply some surds. So I'm going to use the distributive property here. So let's take root 3 times root 7 plus 3. I'm just going to multiply these two out. So it's exactly the same as you did in algebra. You take this, multiply it by this. You take this number here, multiply it by this one here. So what do we get here? Well, we get root 3 times root 7. Here we get root 3 times 3, which is 3 root 3. Now again, here we can use our rule again. That's just 3 times 7. Plus, we can't do anything with this part here. So here we end up with 3 7s, 21, plus 3 root 3. Okay, so that's one of them. Let's do one more. Let's take 2 plus root 3, and then we'll take root 5 plus 4. Let's multiply these two out. Now again, you do exactly the same as what you would normally do in algebra. We'll do this out the long way. We have to multiply this 2 by this and this. We got to multiply this root 3 by this and this here. So I'll just write it out first of all. So it's 2, we got to multiply by the root 5 plus 4. Then we've got to multiply this part here, this plus root 3 by the root 5 plus 4. So this is what we haven't done any multiplying yet. All I've done is just expanded out these brackets, if you like, just to show exactly what I'm going to do. So again, we do what we did earlier. I'm going to multiply this by this one by this one, this one by this one, and this one by this one here. So let's actually do that and see what happens. Here we get 2 root 5. Here we get 2 times 4, 8. Here we get root 3 times root 5. And here we get plus 4 root 3. Now if the signs were negative here, you just got to watch the signs as you multiply. Remember, plus times plus will give us plus, minus times minus will also give us plus, and then finally, if the signs are different, plus times minus or minus times plus, these two here will always give us a minus. In this case we've all pluses, so it doesn't really apply, but just watch the signs in other examples. So okay, so what have we got here? We've got 2 root 5 plus 8 plus, now here this is just 3 times 5, and this is 4 root 3. So just to finish it off, then we got 2 root 5 plus 8 plus square root of 3 5 is 15 plus 4 root 3. Now in this case we can't really add any of these. We have a root 5 here. There are no other root 5s along here, so I can't add this to anything. I have a number here without any square roots or anything like that stuck to it, so there are no other numbers, so I can't do anything with that. Here I've got a root 15. There are no other root 15s there, and I have a root 3 here. So this is our final answer here. Okay, so that's it for surds. There is another video on this called rationalizing the denominator, where you've got to deal with surds. That's a separate video.